Hey guys, so today we are talking about a very common chemical reaction. It's called the combustion reaction. Combustion essentially means burning. So in this process, we are burning a substance and you're burning it with a reagent. And the reagent that we most commonly use in combustion reaction is oxygen. So if we were to talk about combustion reaction, we know so far that it's a burning process. And just by thinking about the process itself, burning, the process gives out a lot of energy. Sometimes that energy comes out in the form of heat. Sometimes the process comes out in the form of light. So regardless of the type of energy that's being emitted, burning gives out a lot of energy from the system. And such reactions are called exothermic reactions. So burning is an exothermic process. It gives out heat energy or light energy. The next thing very common with pretty much all combustion reaction is the kind of products these reactions produce. So the two most common products combustion reaction produce are carbon dioxide. Carbon dioxide, as you know, is denoted by CO2. So you have carbon dioxide as one of the common products of combustion reaction, and the other product from this reaction is water, and water is written chemically as H2O. So you have carbon dioxide and water. So far we know that combustion is a burning reaction. It's exothermic, it gives out heat energy. Its products are also common among various types of combustion reaction, and you get carbon dioxide and water. Combustion is also referred to as the redox process. So it's a redox reaction. Redox basically means a chemical reaction that involves reduction and oxidation. And the substance that's being reduced here is oxygen itself. So oxygen is getting reduced, and oxygen being an oxidant, it oxidizes the substance that you're burning, and the substance here we refer to as fuel. So you're burning a fuel with oxygen, oxygen is getting reduced, and your fuel is getting oxidized. So the process is called a redox process. So both reduction and oxygen is involved. Now, in this video, I'm not only going to talk about the reaction process itself, but I would also show you how to balance different components of the reaction. So I would show you the chemical reaction for very simple combustion reactions, and I will teach you how to balance those chemical reactions, the reactants and products. First off, let's look at the combustion of propane. So propane is chemically written as C3H8. Propane is a natural gas. It's an organic compound, and propane is the gas that we use in from the cylinders to cook. So the gas in your stove is propane. So just from the idea of burning propane, propane is reacted with oxygen. So you're burning propane with oxygen, and oxygen is written as O2. And this reaction gives off, like we mentioned here, two very common products, and these are true for pretty much all combustion reactions. So you have carbon dioxide, CO2, and water. So you're getting, on your product side, you are getting CO2 plus H2O. So this is your first reaction. You're burning propane. Propane is being oxidized by oxygen, so O2 plus C3H8, and you're getting carbon dioxide and water. Now, the next question you want to ask yourself is this reaction balanced? How we know right off the bat that this is not a balanced reaction, because if you look at the carbon here, there are 3 carbon atoms here, but on the right hand side, there's only 1 carbon atom. And in a balanced reaction, you want the number of atoms on your reactant side to be equal to the number of atoms on the right hand, the product side. So the easiest way to balance reaction is to break down each atom and then count the number of atoms there is on each side. So let's draw a line here. So this part of the line is the reactant side, and that part of the line is the product side. Let's take carbon first. So you have 3 carbons. So carbon, you have 3 of them. Hydrogen, you have 8 of them. And oxygen here, you have 2 oxygens. So you have 2 oxygen atoms. So you have 3 carbons, C3, 8 hydrogens, H8, and 2 oxygen atoms, so 2O atoms. On the right-hand side, you have just 1 carbon, CO2. When there's nothing written next to the atom itself, it's taken as 1. So you have 1 carbon. Let's look at oxygens here. You have, from CO2, you have 2 oxygens. And from water, H2O, you have 1 more oxygen. So you have 2 plus 1, a total of 3 oxygens. If you look at hydrogen here, you have H, you have just 2 hydrogens on this side. So you have 1 carbon, 3 oxygen, and 2 hydrogens. To balance this chemical reaction, we first look at the carbon. So we go from left hand side. So we have 3 carbon atoms. You have 1 carbon atom here. So you have 3 on the left side, 1 on the product side. For you to make it 3, all we do is add a coefficient of 3, and that makes it 3 carbon. Now the carbon is balanced on the left hand side and the right hand side. You have 3 carbon in the reactant side and 3 carbon on the product side. Let's look at hydrogen now. There are 8 hydrogen atoms here. Over here, you have 2 hydrogen atoms. If you multiply that 2 by 4, that gives you 4 times 2, 8 hydrogens. There you go. So you have 8 hydrogens on the left-hand side and 8 hydrogens on the right-hand side. And now, not only your carbon is balanced, your hydrogens are also balanced. Let's look at oxygen. So you have 2 oxygens here, which we wrote down right here. So you have 2 oxygens. On the right-hand side, you have O2 multiplied by 3. So you have, now let's modify this a little bit. So you have 6 plus. From water, you have 1 atom of oxygen, but you're multiplying it with the coefficient of 4 plus 4. You have a total of 10 oxygens on the right-hand side. Now to balance this, you have to add a coefficient on the left-hand side. This side has 2 atoms of oxygen, and if you multiply, so you need to figure out a coefficient that you multiply with 2 to make it 10. And we know 5 times 2 is 10. There you go. You have 5 times 2, 10 oxygens here, and you have a total of 3 times 2, 6, and 4 times 1, 4, a total of 10 oxygens also on the right-hand side. That is your balanced combustion reaction for the combustion of propane with oxygen. The next type of, the next combustion reaction we will talk about is also a very common combustion reaction, and it's the combustion of glucose. Glucose is oxidized in your cells, all the body cells. They utilize glucose to produce energy, and that energy helps you to move around and do certain activities. So glucose is also an organic compound, and its chemical formula is C6H12O6. That's glucose. 6 carbons, 12 hydrogen atoms, and 6 oxygen atoms. Just similar to the process that we talked about before, combustion is burning with oxygen. So you're adding oxygen to the 2 glucose, and you're producing, again, these 2 common products. So you have carbon dioxide, so CO2, plus you have water. So let's put in H2O right here. So you have glucose burning with oxygen, giving off carbon dioxide and water. Now, in order to balance the 2 sides of the reaction, we follow the similar process. So you draw a line, and on your reactant side, we will start with carbon again. So you have carbon, you have C6, so 6 atoms of carbon, hydrogen, you have 12, so 12 hydrogen atoms, and oxygen, you have 6 atoms of oxygen on the left-hand side. But you need to understand that there are 2 extra oxygen atoms on the right-hand side. So we add this to this. So 6O6 plus O2, 6 plus 2 gives you 8. So you have 8 oxygen atoms on the left-hand side. Let's write the 8 down here. So you have 6 carbons, 12 hydrogens, and 8 oxygens in total. On the right-hand side, let's look at the number of carbon. Like I said, there's an imaginary 1 here, also an imaginary 1. When there's nothing next to the atom, we take that as 1 atom. So you have 1 atom of carbon. Let's look at oxygen. You have 2 here, 2. Plus from water, you have 1 atom of oxygen. So 2 plus 1, you have 3 oxygens here in total. In terms of hydrogen, you have just hydrogen from the water, and you have 2 atoms of hydrogen. Now let's go back to the left-hand side. You have 6 atoms of carbon in glucose, and you have 1 atom of carbon in each carbon dioxide molecule. So if you notice on this side, you have 6, over here you have 1. All we need to do is multiply that coefficient, so 1 carbon with 6. So the coefficient here is 6, and 6 times 1 gives you 6. So now this carbon 6 is equal to 6 carbons on the right-hand side. Let's look at hydrogen. So you have 12 hydrogens on the left-hand side. On the right-hand side, you only have 2 hydrogens from water. So to balance that, you need to multiply it with a coefficient so that 2 multiplied by that coefficient gives you 12. So we know that 2 multiplied by 6 would give us 12. So we put in 12 here. So you have 6 molecules of carbon dioxide and 12 molecules of water, making 12, this is gonna be 6. So you have 6 times, so we are gonna add 6. The coefficient here is gonna be 6. I don't know why I wrote 12. So the coefficient here is gonna be 6. So you have 6 carbons plus 6 times 2, making 12. So 12 hydrogen here is equal to 12 hydrogen on the right-hand side. Let's look at oxygen here. Oxygen on the left-hand side is a total of 8 atoms. On the right-hand side, you need to modify this number now, because in carbon dioxide, you are adding in 6 molecules. So 6 times 2 makes it 12, plus you are adding 6 molecules of water. So 6 times 1 oxygen gives you another 6. Sorry, not here. So now you have 18 atoms of oxygen. To balance that total number of oxygen on the left-hand side and make this 18, you have 6 oxygens here, and you have 2 oxygens here. If you add a coefficient here, say if I added 2 here, that would change the total number of carbons and the total number of hydrogens, which means you would have to change these coefficients as well. So we will not change this this reactant. We will add a coefficient to this reactant. So you have 2 oxygen here. If you multiply, so you have 6 here plus 2, and all you need is to make it 18. So if you make, so you have 6 to go to 18, you need 12. And you already have 2 atoms per molecule. So if you multiply this by 6, you get 12. So now you have a balanced equation. You have 6 times 2, 12, plus 6, 18. And over here, you have 6 times 2, 12, plus 6, 18. So you have 6 carbons on the left side, 6 carbons on the right side, 12 hydrogens, 12 hydrogens. Now we have 12 plus 6, making 18 oxygens, and 18 oxygen atoms here. And that's it. You have balanced the combustion reaction of glucose. Thank you.